All right, so we established that a linked list, rather than being one contiguous block of memory, it's a bunch of chunks of memory just spread out across your computer. And each chunk points to the next chunk in the list. So each node over here points to the next node in the list, which points to the next node in the list, which contains the data to find the next node in the list, right? The next, again, to reiterate, the next contains the memory location of the next node. It does not contain the actual next node in Russian nesting style format, right? It's the next node's, it's where to find the next node, right? It's its memory location. Similarly, it holds the location of the data that you're looking for. Much like the array, the array list, it doesn't actually store your data. It stores the memory locations of where you find all those data. It's a pointer to like the string, or a pointer to whatever you put into it. All right. So how do you actually like connect nodes into a linked list? I mean, this is one way to do it, right? We create a node that holds a string, right? And we create a new node that has called Tom, that has the data Tom. We have a new node called Rich that has the new node Rich. It has the data Rich stored in it. We have the string here. So we have the string Harry stored in the node Harry, and string Sam stored in Sam, right? And what we do is that we can say tom.next is equal to Rich. So that says that what's going to come after Tom is Rich. Rich.next is equal to Harry. So we store the memory location of Harry in Rich.next. And Harry.next is equal to Sam. So we store the memory location of Sam in Harry.next. So basically this would create a linked list where Tom points to Rich, Rich points to Harry, Harry points to Sam. All right. Generally, you don't have references like this, right? You don't have Tom, Rich, Harry, Sam. You only have a reference to the very first item in the linked list, which we'll call the head. And we'll see that we can also optionally have keep track of the tail. So we're going ahead and going to put that in, right? The linked list, like the array list, has its own stuff. We're going to put in a node E, private node E, head, which says this is the head of the linked list. Okay, and a private, private size, private int size, just like we would do in an array list, which means we can already make our very first instance method for this, public int size, and that will return this dot size, just like we would in the array list. Okay. So we don't keep track of so we typically just keep track of the head. I don't bother setting it to null because it will do that automatically for me. All right. So how do we? So this is an example of how that might look. So the linked list, they have SL list for singly linked list. So here, the head has the memory location of this node, and that has the memory location of the next node, right? This node happens to have the data Tom, this one happens to have the data Rich, right? And even though it looks like we're going to, and just for simplicity's sake, it looks like we store Tom inside of here and Rich inside of here, even though technically what we're doing is that we're storing the memory location of the string, right? So now the question is, how do we build this linked list? Well, first, obviously, we'll need a constructor. So let's build that. And I'm going to keep it dirt simple. Public linked list is equal to, so we build a constructor here, and that's it. I'll actually give it something to do, right? When we build it, we'll say size is equal to 0, right? And head is equal to null. At the very beginning, it will be just completely empty. All right, so next video we'll go over the mystery of we'll go over how we start to build these linked lists, and we'll see the rules for this are fairly simple. or rather, there's really just one rule we have to follow, which when we add a node. All right.